The purpose of this lesson is to learn how to insert data by using a query, how to create views, how to import and export data from and to flat files, how to create tables from a query, how to update and delete information from multiple tables, and how to replace existing data in a table. I'm going to continue using the classic models database that we've used in previous lessons. For this first example, I want to make a database table that simply has a list of all of our customers and the total amount of money that each customer has paid. Now, I could do that on the fly. I could make it a calculated field, but for this example, I'm actually going to make it as a regular table. So what I want to do is I want to get information from our customers table, and I also need some information from our payments table. So what I'm going to do is I'm going to list everything that is in those two tables. So select everything from customers, and I will open another tab here. So select everything from payments. So what I have is a list of all of our customer numbers, and for each particular item that they've paid for, what check they used, the payment date, and the amount. Well, I don't need this information right now. What I need is just simply the customer number and the amount. So what I want to do is, instead of selecting everything, I just want customer number and I want amount. Okay, and in our other table, this is a list of all of our customers and their names. I only want their customer name. For now, I'm going to include the customer number, but when I'm done, I want to get rid of that information. So what I want to do is I want to get the customer name and the customer number. Run this, and now I have a list of all of our customers and their customer numbers. All right, so we talked in the prior lesson where I can actually combine these two tables together, because what I really wanted to say is the name of the customer, then customer number 103, and the amount that they've paid. So what I am going to do is I'm going to get the customer's name and put it beside it. So I need to actually do a join. So we're going to select information from payments and also from customers. So I want the customers table to be our left table. So I'm going to say customers, and I'm going to call it C. And I'm going to join it with payments, and we'll call that one P. All right, so now if I just issue this query, then it'll give a list to me of all of the customers and all the payments, and they'll all be mixed together. So if I have 123 customers and 272 payments, I would have 123 times 272 rows that would result back. I have to provide some sort of criteria to make it limited just to the individual customer. So I'm going to say on, and then C dot customer number is equal to P dot customer number. So I accidentally deleted my P, so I need to put that back here. So now P is our payments table, C is our customers table, and so I'm selecting the customer number from both tables, and I need to also specify up here what these are coming from. So the customer number is going to be C dot customer number, and the amount is coming from the payments table, so P. All right, so I also want the customer name, so I'm going to select C dot customer name. And just to show you that this relationship works, I'm also going to select the same customer number out of both tables, so P dot customer number. Okay, so I'm selecting the customer name from the customer table, the customer number from the customer table, the customer number from the payments table, and the amount from the payments table. When I run this, I get back a list of all of the customers. So if you notice here, we have the name of the customer, the customer's number listed again, so that way we can verify that these work. But I really don't need the list of their customer numbers. So I'm going to go ahead and just remove those. Run this. And now it's starting to look more like what I want it to say. All right, so I don't want it to be the customer name, I want it to be something like customer name spelled out with a capital C. So I'm going to do my as command and then customer name. And our amount over here, I'm going to call this as payments. So I'm just simply renaming these two columns. All right, so I don't want to see each of the individual charges. I want to see a total. So for me to do this, I need to use an aggregate function. So I'm actually not just going to do p.amount. I want the sum of all of their amounts. Okay, so now for me to use a sum, an aggregate function, I have to group it by the customer name. So I'm going to say group by c.customer name. And I also want it in alphabetical order, so I will put it in order by c.customer name. And there's our statement. All right, so what we're doing is we are providing our relationship. We are going to tell it to add up all of the amounts for this particular customer, list the customer name and the sum for each customer, and group it by the customer name, and then put it all in alphabetical order. So I run it, and now I get something like this. All right, so this works. This does exactly what I want it to do, but if you notice, the payments now don't necessarily add up to a dollar amount. I want to fix that. Luckily, MySQL has functions that will let me do that, and the one that I want to use is called format. And what I want to format is this particular column, so I'm going to put that inside of the format statement. So now what I do is I'm telling it to format this thing, but instead of just formatting it, I need to tell it it's a number, so we're going to put it with 2 decimal places. So now I want to format the sum of the amounts such that there are 2 decimal places, and when I run this, I get something that looks like this now. Now if you notice, because I use the format command and it knows it's a number and I included 2 decimal places, now it actually has our commas for our thousands place. I can take this a little bit further. I want the payments to actually show the dollar sign at the beginning. Well, there's no way to simply tell it, hey, it's money, put a dollar sign. So I have to put that in there. There is a process called concatenation, which what that is taking 2 text strings and putting them side by side to each other. So what I'm going to do is I'm going to tell the system that even though this is a number, I want it to treat it as if it were text and let me put it beside some other text. So I'm going to use the concat command, and once again we're going to put this whole thing in parentheses. Okay, so what I'm doing by concatenation is I'm telling it that, hey, we're going to treat this whole thing here as a text string. All right, so if it's text string, I can put it together with other things. So what I'm going to do is I'm going to put a text string in here of a dollar sign. And now what we'll do is it'll put the dollar sign and then have this number following it. So if I run this, now I get something that looks more like money. I can go a step further and put a space in here, which will put a space between these. And now it starts looking a little bit better. So now we have our table that has the customer name and their total amount of all the payments that they have ever made. All right, so where does this table exist? This table that I made exists only in memory. I want to make this be a real table. I want to save it for later. Now, it will not automatically update, so if a customer makes a payment, we're not making a table that does it. We're just simply taking a snapshot of it. Maybe I want something for archive purposes. But what I am going to do is I'm going to add to this command, and what I have is I have a statement already, which is a select statement, and I can put multiple statements together, and that's okay. So what I want to do is I want to tell the system to create a new table that is laid out like this, and then I want to run this query and put the output into that table. So what I am going to do is my typical create table command, and I'm going to call it ticket total. Okay, so then what goes inside of there is these values. All right, so now notice I put a semicolon here, which means this is a complete statement up here once I add the entries to it. And then this one here also has a semicolon, so this is another statement. So what it will do is it'll run this entire statement. When this statement is done, then it will run the statement down here. So I want to add 2 columns. I'm going to have a column called customer number, And like our normal declaration, I have to tell it what our data type is, which is an integer and 11. Now, here's the catch, is that for me to do this, in our original table, so our customers table and our payments table, I have to look at the way that they're laid out, and when I create these columns, they have to match. So I know that in our customers table, the customer number is an integer and it's 11 characters. And I also want to make this not null. So I don't want it to allow somebody to enter null values into it. I'm also going to create a total payments column, which is a double. Now I know that this amount column here is a double, so therefore I'm creating my total payments as a double. And once again, that is not null. And lastly, I need to set a primary key, and the primary key is going to be customer number. Okay, so what it will do is it will run this statement here. It will create this table called ticket total with the two columns called customer number and total payments. It will set customer number as our primary key. And then when that's done, I want it to take whatever was in this query here and stick it into that table. Now, right now, the way that this is set up, it will just simply issue this statement in memory. But I want it to actually insert this information into that new table. So I'm going to type insert into ticket total. And then now what it will do is it'll take whatever comes out of this query, so essentially this table here that exists only in memory, and it will actually commit it to the ticket total table. Now I originally was going to use the customer number, but I actually ended up using the customer name, so I need to fix this. I'm going to enter the customer name as a varchar because that's what it is in our customers table. It's a varchar 50 characters in length. And I also need to specify that our primary key is going to be customer name now. The other thing that I can't do is I cannot use my formatting. When I import data into another table, the formatting needs to not be there. So I need to get rid of my as statements. And I also need to get rid of my concatenation and formatting. So I'm going to take and delete all of this information so that I just strictly have the amount. When I run this query, now it inserts all the information for me. So if I perform another query to select everything, we'll refresh this so we can see it. Here's ticket total. I want to select everything from ticket total. There's our table. Now if you notice, it went back to having the values where they have the extra decimal places because our formatting doesn't exist. But what it does though is it makes it where for archive purposes I have a snapshot of how much this particular customer had paid total in all the payments up until this point. Now the thing is that I just made a table that is static. This will not automatically update. This would be used for archive purposes, but what if I really want to know at any moment's notice what exactly this customer has paid? So what I'm going to do is I'm going to go back to this and I'll put back my formatting, so just undoing. And I want to put back my as statement. And so what I'm going to do is I'm going to do away with the section where we created a table and insert into. So we're just going back to our original query and run it. And what I want to do is I want to create what's called a view. And what a view is for is it will let me run this query as if it were a table. Okay, so instead of creating a table, this time I'm going to create a view. And so I'm going to create a view called customer totals. And what am I creating it? I'm creating it as this stuff here. So what I'm doing is I'm creating a view called customer totals as my query. And what I'm doing by doing this is I'm actually creating a logical table that doesn't really exist that the system will automatically bring up on the fly when I need to use it. So when I execute this, you will see that it created this, and over here I didn't create a new table, but instead what I did was I created a view called customer totals. And so what I can do with that now is I can always do a query, so I can do select everything from customer totals, run the query, and I get the same results. But what actually is happening, but the difference between the two of them is that ticket total will never change. The values in there will always stay the same. However, the view called customer totals that one will change on the fly every time a customer adds a new charge to their account. So the difference is, if I make a table, I'm going to make it static, and therefore I'm going to use it for archive purposes. I'm going to use a view so I can get information that's live without having to retype that entire query. Now, I created views. I really don't want them, so I want to go ahead and get rid of them. And we can drop them just like we do tables. So I can drop a table. So drop table, ticket total, and execute it. And this will delete that table. I can do the same thing with views. I can drop a view called customer totals, and then run it, and it deletes the view. So I have another one over there called total payments that I created earlier, and run it, and now they're all gone. So I can create tables, I can create views, and I can drop them, which means to delete them. But once again, the difference between a table and a view, the table is going to be, if I create that table that has the total for all the customers, that's for archive purposes. If I want it to be updated on the fly, I want to use a view instead. The next thing that I want to work with is the ability to import and export data to what are called flat files. And flat files would be things like a text file or a .csv, which is a comma separated value file. It functions kind of like a spreadsheet. Or I could export to an SQL file. So what I'm going to do is I have a folder that is under my C drive called out, and I want to create a CSV file here that has a list of all of our customers. So the way that I do this is in our query editor, I'm going to perform a query, but instead of displaying it out to the screen, I want to display it out to a file. All right, so what I'm going to do is I'm going to select everything that's in our customers table. So select everything from customers, which if I run this, I get a list of all of our customers. But I don't want it to display to the screen. Instead, I want to put it into what's called an out file. And our out file is going to be somewhere on our hard drive. So in this case, I'm using Windows, therefore it's going to be on our C drive. If I were on a Unix or Linux system or a Mac, then I would have to use the logical path of wherever the files are. So in this case, I want to put it to the C:\out folder. All right, so in Windows, I would write it C:\, and the out folder is the folder I want to put it into. And I want to create a customers.csv file. The problem is, in SQL, a backslash means a delimiter. So I need to fix that. And the way that I'm going to do it is I'm actually going to put 2 backslashes for each one of these. So what that does is it tells it, hey, the thing that's coming next is a real character, so go ahead and use it. Otherwise, you actually get this put into the C drive into a folder file called outcustomers.csv, and we don't want it to do that. All right, so what I want it to do is to put the file out into the C drive, into the out folder, and a file called customers.csv. And what I have to do is I have to tell it how to actually write the files, or how to write the fields to the file. In this format, I don't care how they're actually written to the file. All I care is that I have a customer number column that has a number in it, and a customer name column that has a name in it. Well, in our output files, I could put them in different formats. I could have it as a comma separated value file. I could put it as a space separated. I could put it as a tab delimited. So what I need to do is tell it how I'm actually going to be putting information and how it should be in the sheet. The catch is I'm going to put the stuff into a CSV file, which is comma separated value. And if you notice down here, some of our addresses have commas in them. And these commas will actually break our CSV file if we try to open it up in Excel. So what I need to do is I need to tell it how to wrap things around fields, so that way whatever program opens it knows that this comma actually belongs inside of a field and isn't a delimiter. So we're going to start with listing our fields are enclosed by something. So what are we going to put them in? All right, so whatever I'm going to put them in, I have to put in single quotes to tell it what's going to be in it. So if I wanted to enclose all of our fields with the letter A, I'd put the letter A here. Well, in this case, I want to put a double quote. Okay, so then the next thing is they're going to be terminated by, and this means that in between our fields, what's going to specify the delimiter between each field? Well, we're going to use a comma because we want a CSV file. And then the last thing is, how do we tell the system what actually is a field versus an item inside of the field? So what I need to do is tell it how to escape from each individual field. So it's going to be escaped by, and it's actually a backslash, but once again, our backslashes are reserved. So for me to tell it to use the backslash, I have to put 2 of them. All right, so then the last thing I have to do is tell it how does it make each individual new line, because what will happen is it will just try to write this all out as one long line, and if I were to try to open it up in a text editor or something else, then it would actually open up and all be on one line, which would be very difficult to read. So I need to tell it that it's supposed to use a carriage return and make a new line. So the way that I do that is I say lines terminated by, and then how do we terminate them? Well, we have our backslash R is a carriage return, and our backslash N is a new line. And so we have something like this. So what we're doing is we're telling it to select everything from the customers table, put it into the out file call that is in the location of c:\out/customers.csv, enclose the fields with double quotes, terminate the fields with a comma, so delimit them, and escape out of each one with a backslash. All right, so then our lines are going to be terminated with a carriage return and a new line break. So when I execute this, it will actually create this new file for me. All right, so it says 123 rows affected. Now, if I open up this file, I can actually open this up in a text editor, and I can see that I now have a CSV file. So here's our first record. Notice it's enclosed in double quotes. The comma delimits it, and then we have the next thing is the name of the company, comma, the last name of the contact, comma, the first name of the contact, and so forth. And the reason for the slash here is that the backslash tells it that this is a null value. So if I have something that doesn't have a value in it, I still have to tell it there's something there. So notice this is not enclosed in double quotes. If I didn't use the backslash, this null value would actually be ignored, and we don't want that to happen. So this value right here is being delimited, and it will import that as being a null value. So we have our CSV file, and now what I could do is if I wipe out everything that's in the table, I have a backup copy of it. So let's do that. We're going to delete everything that is in the customers table. So I'm going to delete from customers. Now the catch is if I try to run this, I'm actually going to get an error message, and I'll show you why. Okay, so what it's telling me is that I am in safe update mode, and what safe update mode means is that I can't delete something unless I specify a key column, and this is a protection in the system to prevent me from accidentally deleting something, like an entire record, because I looked for a wrong value. So I actually have to specify the key column, which in this case, our key column, if I look at our customers table, is customer number. So for me to actually perform this, I want to delete everybody, and I know that all of our customers have a customer number greater than 0. So I can actually say where customer number is greater than 0. So what I'm doing is I'm telling you this is the key in my where clause, therefore I'm in safe update mode. It should let me run this query. There we go. So I just deleted everybody from that table. So now if I select everybody from customers, there's nobody there. I've deleted everybody. Luckily, I have a backup copy of it. Here's our CSV file. So I want to import that file back into our database table. So we're going to take all the stuff that's in there and pull it back in. All right, so this is not necessarily used for backups, but it's more used for exporting certain data and importing into another data table, but it works the same way. All right, so what I want to do this time is I'm not going to put stuff into an out file. What I want to do is load data from an in file. So I'm going to load data, and it's coming from an in file that is in c:\\, and once again I have to use 2 backslashes, out //customers.csv. And what am I doing with it? Well, I'm going to put it into a table. Now here's the catch, is I have to fully qualify my table name. So classic models.customers. And the catch is that I have to know how it was delimited, terminated, how it was escaped, how the lines are wrapped and everything in the original version. So I know that I enclosed everything in double quotes. I terminated each field with a backslash. With a comma. I escaped with a backslash, and our lines were terminated with a carriage return and a new line. If I didn't know that, I would have to either ask whoever developed the CSV file or open it up in something like Notepad++ and look at the encoding, because if you show all symbols, it will actually show the new line characters and things of that nature to you. Luckily, I know how we did it, so I'm going to specify fields are enclosed by a double quote. They are terminated by a comma, and they were escaped by a backslash, so I put 2 backslashes. Okay, and then our lines were terminated by a carriage return and a new line character, like this. So now what I'm doing is I'm telling it, load the data from this input file that is located at this location into the table that's fully qualified, which is classicmodels.customers. The fields are enclosed by the double quotes, they are terminated by a comma, and they are escaped by a backslash. The lines are terminated with a carriage return and a new line character, and when I run this, I will get my file or my users back. So now if I select everybody from customers, now all of my customers are back. This is just one way to get data into and out of our MySQL tables. There are other ways to do it that we will discuss in future lessons. We'll actually talk about disaster recovery and backups and restoring and things of that nature. But if you just simply need to get data out, or if somebody sends a CSV file to you, then you actually have a means to get that data into your database. The next thing that I want to play with is creating a table by using a query. So I'm going to select everything from the customers table where the credit limit is equal to 0. And what I want to do is I want to create a table that simply has a list of all of our customers that do not have a credit limit. So I'm going to create this table, and maybe I want to have their name and their telephone number and the contact. So what I can do is I can create a new table that just simply has that information, or I can make an exact duplicate of this table. And that's what I want to do, is I want to make an exact duplicate. The way that we do that is we're going to create a new table, and we're going to call it no credit. And it's going to be like classicmodels.customers. Okay, so now this is actually a separate statement, so I have to end it with a semicolon. I have 2 statements that will get run here. So the first one will create the table. It'll make a duplicate of this one without any data in it. So it actually just simply models the structure of the table. And then this statement will actually put data into that table. All right, so in our customers table, we actually have 123 customers. In our list of customers with a credit limit of 0, we have 24. So what I'm actually going to be doing is creating a table that should have 24 records in it. Before I can run this, I need to tell it to input this information into this particular table. So I'm going to say insert and then list the name of the table where it's going to go. So it's going to go into no credit. So we create the table, we call it no credit. It's going to be modeled like our customers table. So it has the structure of our customers table. We are going to perform a query, which we select everybody from the customers table where the credit limit is equal to 0, and then insert that into no credit. Execute this query, and now we have a new table. So if I come over here and refresh, now I can see that we do have a table called no credit, and if I want to see everybody that's in that table, there's everybody. So now this table has 24 records. It's just simply the people that have no credit limit. Everybody else is in the other table. Sometimes you'll encounter a scenario where a customer needs to get a new customer number, or let's say I'm using something as a primary key and I need to make changes to it. What will happen is I will have to go through every table that has that customer in it and change their customer number. And that's exactly what we are going to do here. So what I want to do is I want to see everything from our customers table. And here's our customers table. You notice everybody has a customer number. So what I want to do is this customer here, number 103, they need to change their customer number to 3001. All right, so what I can do is I can look at each of our tables and I can see there's a customer number in here under customers. There is not one under employees. The no credit is one that I created. We can go ahead and drop that. Our offices table does not have anything to do with a customer number. Our order details does not have a customer number. Our orders table does have a customer number though. Okay, so far I have orders, customers, and then if I come down, I also have payments that has a customer number, and then products does not. So I need to change this person's customer number in not just one table. I have to do it in all three tables. And so what I need to do is I need to come up with some way to very easily change their number without accidentally changing it to the wrong thing. Or if I do change it to the wrong number, I need to make sure that it gets updated to the wrong number in all the tables. All right, so what I would do is I would do a transaction where we update the customers table and we set the customer number equal to something. And then we update the payments table where we set the customer number equal to something. And then we update the orders table and set the customer number equal to something. The problem by doing that is I very easily could mistake my actual number. So let's do that real quick. I'm going to say update our customers table, and we're going to set the customer number equal to 3001, where the customer number already equals to 103. Okay, so that works. All right, and I have to do that with the other one. So I'm going to say update, and then we'll do payments, and then we're going to set the customer number equal to 3001, where the customer number is equal to 103. Oh, wait a minute, I just mistyped it as 130 and I don't realize I did it. I now end up breaking our database. So I don't want to do that, but I am going to type out the rest of this command and I'll show you how this actually will work without having to type them a whole bunch of times. So I'm going to update orders. Same thing, we're going to set the customer number equal to 3001, where the customer number is equal to 103. Okay, so this would actually do it, but like I said, this one right here would be broken because I have the wrong number typed in. Okay, so I'd have to go back and I'd have to fix it. Luckily, I caught it, but if I didn't, there's no easy way to go back and find that record and fix it without manually going through the whole database. All right, so what I need to do is I need to use what are called variables. So I'm going to create a variable by using the set command, and then I'm going to call it @old cust name. So this is the old number, sorry, the old customer number. And I want to set it equal to something, and to set it equal to something you put a colon and an equal sign, and then the old customer number was 103. And so I also want to set a variable for the new customer name, or customer number. So new custom and colon equals to set it equal to 3001. All right, so now what that does is lets me down here, instead of saying 3001, I can say new cust number, because this is what the new one's going to be. We're setting it to the new one where it is equal to the old one. So @old cust number. Okay, so now I want to change it here. And this is the old one. And do the same thing here. So @new custom, and this is the old one. So @old custom. Now each one of these is a statement, so they each get their own semicolon. But what this does is creates what's called a session variable, which means it's good for all of the statements that occur within this same query window. So this session variable will get created. It gets changed to 103. This one gets created, is changed to 3001, and it will let me run it. All right, so I think I'm ready to actually do it. Well, the thing is that I need to do what's called a transaction. Because what would happen is it will issue this update query. Great. Then it will issue this update query. Great. And it will do this one. What happens if this one works, but then this one fails? Then what will happen is it's broken. So what we want to do is we want to use what's called a transaction. And what a transaction does is it actually makes it where if any one of these statements doesn't work, it won't actually commit the change to the database. So what we want to do is we want to tell it that this section is a transaction. So we're going to start our transaction here. And then we're going to come all the way to the end, and we're going to tell it that when the transaction is done, we want it to commit the information to the database table. So what will happen is if it runs the first one and the second one fails, then none of these will get committed to the database. They only get committed if they are all successful. All right, so I should be able to run it, except for one other thing, so I want to show that to you. I'm going to run this, and it says that I'm using safe update mode. Now what safe update mode is, same thing as before, I didn't reference anything on the key column. Well, the problem is their customer number may or may not be the key, and in this case I'm using a session variable so it doesn't check to see if it's the key column. So I have a couple of options. My options are to flat out turn off safe update mode for the entire system, which means everybody can make changes to it without regards to using the key, or I can do it temporarily in here. So I have one more set command that I can use. And what I want to do is I want to turn off safe updates just for the purpose of this query. So I'm going to set SQL safe updates equal to 0. So I'm going to turn off safe updates, and then if it gets committed, or when it gets committed, then we're going to turn it back on. So SQL safe updates equal to 1. So now what it will do is it will create the session variable. So it puts these values into this variable names. It turns off safe updates. It starts a transaction, which means that all of these statements have to run and be successful. And then when they're successful, then they will be committed, and it will turn safe updates back on. So now when I run this, now I get where it actually did it. It actually let me change their name. All right, so if I go and look at the customers table, so select everything from customers, run this, I now no longer have a 103. So I want to see 103. So let's do this. So where customer number is equal to 103. Doesn't exist. Okay, but if I go and search for 3001, now I get our customer back. But not only did we do it in customers, we did it in payments, and we did it in orders. So now what I've done is by creating a transaction, I've made it where we update all of them or none of them. It can't just do one of them and the other ones fail. It has to be successful for all of them. And we used a session variable, so that way we didn't have to list the name or the number to be used for each of these. So that way if I accidentally change it, once again, I don't break anything because they would be broken in all of the tables, and therefore they'd actually still work out because it would still be a unique value. So in this case, I have a session variable for the old number, session variable for the new one, and then we just simply reference those in all of our statements that belong to our transaction. The last thing that I want to do to this database is we received notice from the vendor that the price of their items is going to be going up, so we should increase our sales price. So what I want to do is I want to look at everything in our products table. And every item in here has a price that they call MSRP. So what I want to do is I want to look at the product code, the product name, and MSRP for each of the things that's in this table. Okay, so this is what we have as our table, And right now, our Harley-Davidson Ultimate Chopper is $105.27. But they have told us that the price of these items is going to increase. So what we actually need to do is we need to perform a query that will let us increase the price of all the stuff that's in that table. So what I want to do is I want to update the products table, and I'm going to set the MSRP column equal to whatever the MSRP is right now times whatever I want it to be. Now the thing is that I want it to be a 10% increase over the 100% of the purchase price. So I'm actually going to increase it by 110%. So I'm not going to increase it. I'm going to set it to 110%. So I'm going to set it to 1.10. So this is the same as 1 times whatever the price was now plus an additional 10%. So in other words, increase the price by 10%. And I want to do this for all of our products, but once again, we have a column that we're modifying that's not the key column. So if I look at the columns here, our product code is actually our key column. And so what I need to do is I have to tell it to do it for all of these. Well, what I know is that this is a text value. It's a varchar. And so what I want to do is I want to say that for all of our products that have a product code greater than no value at all. So what I'm going to do is I'm going to make a where clause that says where product code is greater than, okay, now if it were a number value, I would say 0. But in this case, it's text, and I want to say that it's greater than nothing, so I'm going to put it in 2 sets of double quotes. So now what it does is if the product code is greater than no text value listed at all, which remember is different than null, this just simply means that nothing was entered, we're going to update the MSRP. So right now, our Harley Chopper was $105.27, and when I run this query, it will take all our products and increase the price by 10%. All right, so watch our price here. This $105.27, when I refresh, that price now went up. But what happened was, when I performed the calculation, it now has additional decimal places, which we really don't want in our system. We want them to be in the format of money. All right, so what I'm going to do is I'm going to put it back by dividing by 1.10. So now when I go back, now it's back to 105.27. So this time I'm going to multiply, but I want to format this. So I'm going to use my format command. And how do I want to format this? Well, I want to format where the MSRP times 1.10 has 2 decimal places. So now what I'm doing is I'm telling format this value, then stick it into the MSRP so that way it only has 2 decimal places. Run it, and then now when I come back over here, my 105.27 should increase, but now it is increased to 115.8. Now there are actually 2 decimal places, but by default it will only show me the first decimal place if the remainders are 0. So there are a bunch of zeros out here, it just ignores those. But when we pull this up in a program, we would actually be able to format this and we would see that it's 115 and 80 cents. Same thing here, this is 30 cents and then this one is 91 because there are 2 decimal places. But if I scroll down and look, you will notice that they all have no more than 2 decimal places now. So what I've done is I updated the table, I set the MSRP equal to the MSRP, whatever's there right now, times 1.10, so 1 plus 10%, and then I formatted it with only 2 decimal places, and because we have safe update mode set, I had to tell it that we're looking at the product code for all of our products where the product code is greater than nothing. In this lesson, you learned how to insert data by using a query, how to create views, how to import and export data from and to flat files, such as CSVs, how to create tables from a query, how to update and delete information from multiple tables, and how to replace existing